We will determine the mass of a 10 ml Erlenmeyer flask on an analytical balance. It weighs 17.6778 grams. Working in the hood, we will add our liquid unknown, which is unknown A, to our Erlenmeyer flask. We will then insert the rubber stopper in, getting the liquid to just rise through the hole in the top, and then we will dab away any extra. We will dry the outsides of the flask entirely, leaving the Kim wipes in the hood so that the liquid unknown will evaporate from them in the hood environment rather than in the classroom. We will now weigh our liquid and Erlenmeyer flask, and it weighs 26.7453 grams. We have removed the liquid from our flask and we have dried our flask using acetone. Now we will add water to our flask in an effort to determine the volume of the flask. The water that we will add is distilled water at a temperature of 22.6 degrees Celsius. You will need to look in Appendix 2 to find out the density of the distilled water at the 22.6 degrees Celsius. So now we've added water to it, we will wipe away the sides and we will measure the mass on the same analytical balance. The mass of the flask with water is 29.0966 grams. Now we are doing part B, which is working with a metal. Our metal is unknown A, and it looks to me like copper metal. You will determine the density of it so you could compare your experimental density to the accepted density of the metal. Okay, so we will add it to our flask. And we will measure the mass of our flask with copper metal. We will now determine the mass of our metal and flask. The mass is 45.6696 grams. We now add water that is at the same temperature as it was before, so its density is what we used in part A. We add water to fill the flask, and we dab away any water that spills over. Now we go and weigh this. The mass of our metal with water and flask is 53.8165 grams. For part C, we are measuring the volume and the mass of our metal sample, sample A, using a less accurate method. Okay, so to get the mass, what we have is we've zeroed a weigh boat on a centigram balance, so we should see 2 sig figs, so we zero the instrument, and then we add the metal sample to it. It weighs 27.97 grams. We have water in a 100 ml graduated cylinder, and its volume is 41.1 ml, 41.1 mLs. Now we add our metal sample to it, because the metal of course has volume, and it will push the water up, and from the difference we will be able to determine the volume of the metal. So it is at 44.2 mLs. 44.2 mLs.